let's write some tests that check the functionality we just wrote with the nonce value and the proof of work leading 0 condition. Head to the block.test.js file. First up, let's check that it generates a hash that matches our difficulty with the leading zeros. So let's write in that unit test at the bottom and say that it generates a hash that matches the difficulty. Then we have our arrow function as the second parameter to this it function. In order to write this test, we'll want access to that difficulty variable that we declared in our block class. So let's head to the block.js file. As seen, we're already setting the default export of our block to the block itself at the bottom of the file. So to make sure that both our testing file and this block file have access to the same constant, let's make a new file that's devoted to declaring configuration constants just like the difficulty constant. So at the root of the project, let's make a new file called config.js that is devoted to this specific behavior. Within this file, let's grab the constant that we declared at the top of the block. So go to the top of the file, and then we'll grab this constant that we declared over here. And then let's paste it into our config.js file. So that way it's declared over here. And as the module for this config, let's export an object that contains our difficulty constant. So notice that we're using the ES6 destructuring syntax to automatically set a key that is the difficulty name, and then use that value automatically by only writing it once within the object. All right, great. Now we're exporting it from this config.js location. Now within our block.js, since we're using the difficulty in the file over here in the mindBlock function, well, we need access to that constant now. So let's make a constant of difficulty set equal to requiring the config file. So notice that right away, we're using ES6 destructuring syntax to grab the difficulty constant that we shared in the object of the config.js file that is one directory above. Great. Likewise, we can use the same technique to grab the difficulty constant within our testing file as well. So right at the top, let's do the same thing. We're going to grab the difficulty that is at the config file that is one directory higher with .. And notice that we're using the destructuring syntax, so have a pair of curly braces around the difficulty const requirement. With that, we're prepared to write the test that checks if the generated hash starts with a string of zeros up to the length of this difficulty number. So we'll immediately expect the hash in this block that we're creating first of all has the substring from 0 up to the difficulty that matches the same length of zeros. So we're going to have an expect function. The input is going to be block.hash, and then we'll get a substring from 0 up to the difficulty. So let's go up to the difficulty. And then we want this to equal a generated string of zeros. So again, we can use the character 0 and then repeat that up to the length of the difficulty. And then what we find is that this should be a certain number of zeros. And since the difficulty is 4s, this should eventually equal 4 zeros. All right, great. Let's run our test in the command line now. So go ahead and open up your command line so that we can run the test. Now here we are in the command line. So let's run npm run test within the sfchain directory. If all goes well, it should just take a short moment to generate all the blocks since it now has a proof of work condition to pass. But eventually, we should find a complete suite of passing tests, which this time took around 10 seconds to generate. Awesome. This means that our new test for the leading zeros in our block hash passed. So we know that the nonce value is indeed incrementing in order to generate a new hash that matches the proof of work leading zeros condition. Notice that the test suite again takes a bit of time to run. Considering that the difficulty is set to 4, this is actually expected since it takes some time to find a hash value that starts with at least 4 zeros. We can speed this up a little bit by going into our config and then changing this to a 3. And as we do so, it takes around 2 seconds to do it this time, or actually around 3 seconds. which is much faster than the 10 seconds it took before when the difficulty was set to 4. To explore this nonce value a little further, let's add a console.log of the block's toString representation in our new test. So right in the new test, after the expect, let's console.log the block and its toString function. And as we do so, back in the command line, what we have is a new block in our command line. And then look, there is a nonce value that took around 7,000 loops to generate. And notice too, the hash value starts with 3 leading zeros. Your nonce value will likely be very different from mine, considering that we have different timestamps, and both the timestamp and the nonce are considered when generating this hash, but still it should take around this time, considering the difficulty, in order to generate a valid hash. Great, that completes testing the nonce value for the proof of work system we started adding. Next up, we'll create a system of dynamic difficulty based on how frequently we want our blockchain system to generate new data. After all, currently, the difficulty is statically declared in our config file. Since the difficulty is always the same, it will take roughly the same amount of time to mine each block. But we want our blockchain to dynamically adjust the difficulty as new miners are added to the network. That way, blocks are mined at a rate that we determine, something like 5 seconds, a whole minute, or even 10 minutes if we were to follow the Bitcoin paradigm, even as new miners and more computing power is added to the system. All right, let's get to it.